Researchers, developers and engineers of the European Research Project Direction have created 2 near-zero energy buildings to test which energy-saving technologies are suitable for commercial buildings in the coming decades. Initially, they modelled the energy consumption using computer simulations, optimised it, and then started to construct the buildings with all its energy-saving features. One prototype is called NuOffice and is situated in Munich, southern Germany. After 18 months of operation, the NuOffice building has demonstrated that its energy consumption is 73% lower compared to a standard office block with no energy-efficient technologies. These results have shown that the energy demand of buildings can be predicted quite accurately with the help of elaborate energy models. Instead of glazed facades, as they are known from many modern office buildings, the NuOffice has smaller-sized windows. The advantage? There is no risk of overheating during sunny days, and a loss of energy on colder days is avoided. Additionally, the windows are triple glazed to ensure an optimal insulation. But the most important detail of the energy-saving concept is found in the basement, the completely new heating system. Romano Schillinger, civil engineer from the BBS Planungsgesellschaft, explains its construction.
Die Betonkerntemperierung ist eigentlich ein Wort dafür, dass man in der Beton...
Tube loops inside the thermoactive ceiling enable us to regulate the temperature inside the concrete. Heating or cooling the mass of concrete from the core results in a constant warming or cooling of the rooms. In the winter, the office is connected to district heating to heat the concrete. In the summer, well water is used for cooling the concrete from the core and to cool the rooms.
Zur Verfügung, den Betonkern abzukühlen und entsprechende Kühle in die Räume zu bringen.
Hubert Haupt is the owner and proud for its visionary approach. He has been accompanying the construction from the beginning.
We have thick exterior walls, so we don't have to cool in the summer, and we accumulate energy in the winter. We don't need to heat extremely in the winter, which benefits the tenants' expenses for energy costs. We worked intensely on simulations, the relation of wall and window. On the one hand, we wanted to optimize the energy efficiency. On the other hand, we wanted to have ideal daylight conditions in the building. There were many details we considered within the topic of sustainability.
The combination of different energy-saving features has given the NuOffice international recognition. In 2013, it was awarded a Green Design Certificate in Platinum, called the Leadership in Energy and Environmental Design, short LEED certificate. A further success of NuOffice is standing right next door. NuOffice 2 and 3 are the follow-ups of NuOffice 1, built to satisfy the request for sustainable and comfortable office buildings in Munich. But on a global level, the biggest impact on building efficiency will be achieved in hot countries. And here, energy usage is primarily determined by air conditioning. Direction has therefore created a second non-residential building in Spain that is exposed to hot summers and cold winters, CARTIF III building in Valladolid. This construction, existing of 1/4 offices and 3/4 warehouses, includes many off-the-shelf technical solutions to improve the overall energy efficiency. They include, for example, automated louvre blinds and solar panels on the roof. But the building also has a unique feature to reduce energy consumption that is directly linked to the design of the building. Álvaro Núñez has worked on the development of this innovative architectural concept.
El mayor desafío de la concepción del edificio fue el concebir una forma arquitectónica.
The main challenge of the concept was to find architecture that would allow us to take advantage of the environment to save the most energy. So we had many discussions, thinking of the best orientation for the building, the best form, the best way to implement renewable energy technology, for example, solar and wind power, to finally obtain the highest savings possible.
El sol, el viento, etcétera, para conseguir el mayor ahorro del edificio.
By setting the ground level of the building 3.5 meters beneath the soil, and by including patios between the wings, the overall temperature surrounding the building stays cooler. In the basin, trees and the cool underground soil keep the air temperature around 6 degrees Celsius lower than the air that is exposed to sunlight. As the air on the upper levels is heated by the sun, it rises out of the patio, and due to the pressure difference, cooler air from the bottom flows upstream. This circulation pattern continues throughout the day and cools the upper levels by about 3 degrees Celsius on average. Despite the unseasonable climate conditions in 2015, the building comes very close to its aim of a primary energy demand of 60 kilowatt-hours per square metre per year. Some system improvements to obtain an even better performance of the building are being accomplished so that a further reduction of the primary energy use is expected. Reducing the energy consumption is crucial in the combat against global warming. The building sector is responsible for more than 30% of global energy demand and around 20% of global greenhouse gas emissions. Buildings like NuOffice and CARTIF III, which seem ordinary and built to serve a purpose, will make the difference in slowing down global warming.